Here are some things to watch out for when you're looking at correlation coefficients. It may be that there's a nonlinear relationship among the variables, but that's not being captured by the correlation coefficient, and so you see a low correlation coefficient, even though there is some kind of nonlinear trend there. Another situation is that outliers can have a pretty significant impact on the correlation coefficient, and they can really reduce the correlation coefficient, even though the bulk of the data shows a pretty nice linear trend. The last thing to look out for is ecological correlations. This is a phrase that we use when we talk about correlations of averages. So here's an example. You're interested in looking at the correlation between math SAT and maybe verbal SAT or critical reasoning SAT scores. And let's suppose you get your hands on some data that about average math SAT scores and average critical reading scores. And you see that those averages in each of the 50 states are incredibly well correlated. It may then turn out, though, that the individual students, when you look at those individual students, you'll see that their math SAT and their critical reasoning SATs are not really that well correlated. It's only the averages that are correlated. And people make this mistake all the time. Let's have a quick look at a demo to show this. Here's some SAT data about state averages. And in particular, we've got critical reading scores and math scores for each of the 50 states. And if you plot these critical reading scores against the math scores, you see this incredibly good linear trend among the averages, right? The correlation coefficient turns out to be 0.98. That's incredibly close to 1. And so we're looking at these and we're saying, wow, that's amazing. Math SAT and critical reading SAT are measuring almost exactly the same thing. But that's not quite correct. It's the statewide averages for math and critical reading that are highly correlated, not the scores for individual students. And this is the kind of error that one can make. Here's another thing that you might, kind of error that you could make, and one that's worth knowing about. You might look down here and say, whoa, there's some state where people are getting 450s, very low SAT scores for math and critical reading, compared with some states where the students are scoring above 600 in both. One of these states might be the District of Columbia, and the other state might be a state like Colorado. And it's true that the average scores for the students in the District of Columbia that take the SAT are quite a bit lower than the average scores for the students that take the SAT in Colorado. But then if you look a little bit more carefully, you'll see that only 14% of the students in Colorado take the SAT, and 100% of the students in the District of Columbia take the SAT tests. In DC, we're making the SAT tests mandatory, and we're paying for them for the students in order to ensure that lack of SAT testing isn't an obstacle for students that can't afford to take the SAT and want to go to college. On the other hand, in Colorado, it's a Western state, and Western states tend to use the ACT as opposed to the SAT. The bulk of their students are not taking the SAT. The only students that are taking the SAT are students that are interested in applying outside the state and often to elite schools. So we're comparing the elite students of Colorado versus every student of the District of Columbia. And that's why we see such a huge disparity in their scores, in their at least average scores, right? So that's a thing to be wary of. Sometimes there's some extra confounding variable, right? Some other variable that explains this discrepancy, and here it's the participation rate in each of the states. Let's move on to talk about some discussion questions. For each pair, which one of these will have the higher value of R? The left pair, the left item of the pair, or the right item of the pair? Pause the video for a moment and then make your choices, and we'll review the answers on the next slide. Okay, here are the answers. So in A, on the left, you see like this blob of points, and on the right, you also see a bit of a blob of points, but there does seem to be more of a linear trend among them in the rightmost situation. And not only that, but it's a positive linear trend. Okay, look underneath in B. You can see a very clear trend on the left and a slightly less clear trend on the right. But we've selected the rightmost to have the larger R because the trend on the left is negative, which means that you get a kind of maybe fairly large negative value, right? Like maybe negative 0.7. Whereas in the right, maybe you get something like negative 0.2, indicating less of a linear trend. And so here, the R number on the right is less negative. It's a higher value. Okay, let's have a look at C. In C, we see a positive trend in both pictures, but on the rightmost picture, we see some outliers down near the bottom corner that are pulling our linear trend kind of down. We're not seeing as clear a linear trend from those points, and so we select the left one for the higher R value. And in part D, we're selecting the right one, even though we don't see a linear trend here at all. I would expect R on the right to be about 0. I see more of a cubic trend there. But the R value on the left looks pretty negative. It looks like it should be indicating a pretty linear trend, and it's downwards. It's a negative trend. So R might be, say, minus 0.7 on the left, and here on the right, it looks like it's closer to 0. So the rightmost value is larger. Here's one more set of discussion questions, true or false questions. Have a look at these, pause the video, decide on your answers, and then continue. Okay, here's the answers. If X and Y have a correlation of 1, then one must cause the other. That's not true. No, correlation does not imply causation. This is a standard kind of error, and we've seen the kind of problems using the correlation between ice cream sales and crime rates. Correlation, they're very highly correlated, but ice cream sales don't cause crime. There could be confounding factors, right? In 2, that's also incorrect. The correlation of X and Y could be close to 0, but it's quite possible that knowing one would help us predict the other. There could be a quadratic trend, or there could be some other kind of trend that's just not that's not a linear one. In 3, this is true. If X and Y have a correlation of minus 0.8, that means that they're close to a linear association, and that association should be negative, and so that's true. Here's a little picture to leave you with. A pretty scary pumpkin from Halloween inferring causation from correlation. Don't be the one to make that error.